What about stone brick?
Stone brick, yeah, I think stone brick.
Recycled brick?
Actually, that's not many compared to the number of brick buildings that are appearing out there in the kind of random sample of architects. I hate brick. When I was a graduate engineer, I went to work with Whitby, and the dishwashing that you would give the graduate was designed with brickwork. And bricks are incredibly weak, incredibly fiddly. You have to stick wind posts in and talk to wind post manufacturers and all these laborious kind of
set on the joints, which you can see on that side. So the stones are locked together over that fold. And so we tried it at scale and it failed, and then we figured out what was wrong with it and we got it working. So it's a load test. The barrels are full of water. And that's the final one before the Jubilee balustrade went on. So this is quite challenging, and we had to develop a really complicated analysis method to do this, and we were quite, actually it's kind of a theoretical endeavor, and then they built it and sent us a photo, and we were, but we've done, I don't know, 60 or 80 of these all over the world in earthquake zones in the States, in Turkey, France, UK, Sweden, everywhere. But it's just such a succinct and simple thing, and the stair in that case would have been a steel frame clad in stone or a concrete stair, quite thick, clad in stone. And you can imagine, not only is it much bigger and heavier clad concrete, but you had to do more cutting to cut it and make it work, false work. So it's quite a succinct solution as well as an elegant one. So as it, we've done hundreds of stairs, all sorts of different shapes, and this, these are all cut by hand actually, which is quite amazing. But so we kind of learned about stone through designing staircases for rich people. So it's paying fees, and they want to do something audacious, so there's room to experiment. But what we were really more interested in is doing ordinary buildings and bringing stone down from its status as a kind of high-end material to being a very ordinary material that you just use for, instead of concrete or timber or steel. So this is, Taha's building in Calatrava, concrete slabs inside and a core and no columns. And the facade is completely load bearing. Obviously the concrete contractor and the stone contractor are different people. So if they're on site at the same time, they're fighting over the crane continuously. So we divorce the two activities, and it's not ideal to have to do that. But we built the concrete and we left all the backpropping in. So the concrete frame is standing there on the yellow props for a while, and then we built the stone in afterwards, and then removed the yellow props afterwards. There are 3 finishes in the stone. They drill and plug and feather, split the stone, and then they liberate off the belly frame, which exposes all the fossils and stuff, and then they store it. So those 3 finishes are pretty much randomly distributed across the building, and saved a lot of money, as well as giving the kind of the construction gave some reflection to the architecture, but also it's the most expedient way of sticking stone in the building. No fuss, no carving, no extra work. And the thing completely supports that concrete frame. So, it's not the same as this is carbon negative, but it's a concrete frame with it's not that low carbon. But what's for us interesting is that it shows that you can build a load-bearing stone frame at some scale, and it's not a lost art, and you can build the solid stone blocks, and you can use it as a structural system as well as decoration. So I think it's a kind of precedent-making project. So with the reinforced stone, what we, rather than doing staircases, what we're quite interested in is just making beams and columns and slabs. So the stairs are really complicated to make and to analyze, but making stone blocks and drilling a hole through the middle and put a cable through and stressing a cable, steel cable goes through there, sort of cuff and wedges, you pull it with a jack and cuff, and the wedges stop the cable from going back into the stone. And you grab the cable in, you can do beams, columns, slabs very, very easily. And actually about the same size as a steel component. So same depth, same width, and something like a 15th of the carbon footprint. So we did a lot of, so we have an R&D budget of about £2.50. But we've done quite a lot of, with the help of the stone masonry company, we've done a lot of testing, and Wendell Sebastian from UCL, so we've done a lot of structural testing. And we were thinking, if you burn limestone, you get cement. So if we have a fire in a limestone building, we're going to end up with a nice, neat pile of cement afterwards. So we did a fire test. And again, because concrete has water inside, when the concrete gets hot, the water turns to steam, and it's trapped in the pore structure of the concrete. And so it explosively falls and exposes the reinforcement, and the reinforcement melts and the beam falls down. Whereas that doesn't happen with limestone, because there's not that much water in it, and the capillaries are open. And so this beam just sat there for 3 hours, and and it's a loaded test on a 7-metre span. So we've got a really, with that particular stone, maybe other stones are different, but with that particular stone, we've got a very good fire resistance. When we did the new Stone Age exhibition at the Building Centre, we were proposing it for a commercial building, and office floors want to have 12-metre column-free spans for Christ knows what reason, when they're going to stick meeting rooms and desks everywhere. I don't understand, but yeah, so we made a stone beam span 12 metres. That's designed for office load. It's a 75mm top slab, 450 by 200. 2 cables through the bottom, 1 cable in the top, so you can lift it with the crane without breaking. You can see that there's sort of slightly castellated top where the top plates are grabbed by the beam, so the whole thing is composite. And then more recently at the Royal Academy Summer Show, so here we're making the thing a T shape. It looks like a concrete T section, but very intentionally to show it as a sort of familiar form. You see what I mean? So it's like a concrete. We got recycled granite from a demolished building. So the brown bits are granite, and then in between is unloved Portland stone, roach bed. So all quarries, when you quarry stone, usually it's highly regulated on aesthetic grounds, and maybe a quarry, only 20% of their production is sold. Every quarry has a great big pile of unwanted blocks because it's the wrong colour. People are so selective. So even if you go to marble quarries, they fence off the quarry. You can imagine the conversation. Shall I put up chain link fencing? Don't be an idiot. Use 1 metre cubed Carrera marble blocks. So cheaper for them to use the waste block to make fencing. So there's all this stone that isn't used, and obviously as an engineer we don't care what colour it is particularly, it's strong enough. But it's a 5.5 metre cantilever. It's just pivoting on the timber thing, 200mm deep. And now we've done quite a few bits of buildings and other buildings, but this is a £75 million project, residential project, and this is not an expedient way to build stone, not economical, I should say, in the slightest, but it's got scale. And so this is the whole stone structure, and these are all the beam elements within it. So we have quite a few floor slabs, lots of beams dotted around. Inside there, 10-metre span floors, and this is the beam factory. Not much investment to make those beams. It's not much equipment there. It's not a blast furnace. It's just it just saw these things up and stick them together. So you can start a beam factory very, very cheaply. Slab factory. That's the 10-metre span. So we're kind of interested in. So this is the architectural foundation. Interested in form. So the others, one thing is what material do you use, the other thing is what form do you choose. And so I really enjoy these experiments with hanging things. What we vernacular means rope, or related to rope. So when we talk about vernacular structures, you're normally talking about arches, but it comes from vernacular because you hang the rope to find the catenary shape to give you the shape of the arch. So anything that hangs in tension works in compression. So I really love making these crazy experiments with bits of string and cloth and stuff and plaster of Paris. So these things are really informative about what kind of shapes you can build, and particularly so in the big project that I was talking about before, we have an underground swimming pool, and so basements. Everyone's building rectangular basements. Well, as I was saying, when any engineer puts anything in the ground, everything is circular. So sewers, sewer pipe, tubes, shafts, Brunel's shaft, that everyone's making circular things in the ground because they resist the soil pressures perfectly, can be very, very efficient. The minute you make it rectangular, everything needs to be 600mm. So here we're looking at how we design the enclosure for an underground swimming pool. And what works in tension works in compression. So it's exactly the same as hanging these things upside down to find the shape. The pressure inside this balloon, I'm using the balloon word, the air pressure pushing out against the strings is exactly the same as the soil pressure pushing in. So you can find the shape of a ribbed vault from that. So we're building, it's not finished yet, but it's like 70 meters long. So we put in sheet piling, build the quite thin stone vault structure, bury it, and take the sheet piling out again afterwards. So the form is kind of a key to making things more economical. I was in Mallorca, and Ibadi, who are the part of the Balearic government that are making housing, are designing a lot of social housing using stone. And they're saying they have obviously a huge amount of limestone and nothing but limestone in Mallorca, and they're building vaulted roofs and walls, and they're getting back to their traditions and reducing the carbon footprint of their construction. And the guy was saying, there are 7,000 spoken languages in the world. Why isn't there that diversity in architectural language? Why is everyone building with concrete? Whatever. And I was thinking about that and thinking that we here are sort of adopting DLP as a decarbonising solution. But that's, this is Mallorca, that's how they build. This is Switzerland, and that's how they build, or Austria or Finland or whatever. It's not really us. So we've done a whole series of buildings from very small domestic projects up to quite bigger ones, culminating in this one with Lauren Stroud, and it's the Anna Freud Centre, big basement and a refurbished Victorian building, but all the above ground structures are composite timber and concrete frame. So we have a timber frame, concrete slabs on top. It's Baubucher stitched into coach bolts so that the two things work compositely. But the reason is, so we were talking to our M&E, Paul Downs, our M&E director, and saying that if it's a concrete building, we wouldn't need any air conditioning. We open the windows at night and the building cools down. And if it's a timber building, we need loads of air conditioning. So we were like, well, do we have to make 300 millimeters of concrete? How much do we need? So we were analysing what thickness of concrete we needed to get enough passive conditioning to eradicate air conditioning from the building. And the former building we did was 50 millimeters, and this is a bit thicker at 90 millimeters. So we have just enough mass to avoid air conditioning and then support it on timber. So the frame is kind of balanced carbon, very low carbon, very lightweight, some negative carbon in inverted commas in the timber. But the problem with this is obviously the carbon footprint of the concrete. So it's all exposed inside the building. What's the next step? So we continue to do tiny domestic jobs, and we do quite big jobs. So when we have a new idea, we try and find a victim with a domestic job to try it out on, and then gradually kind of graduate it through the project side. So this is a very early iteration of this idea, and it's a back extension in Primrose Hill. It's a Georgian building, you have a big timber. Big timber beam holding up the back of the house on stone columns, stone beam along the back, and then timber joists and the stone in between them as a composite infill. You can see that the stone reinforced stone beam on the timber prop, and then timber joists, stone in between. So this seems to me, for a country with a little bit of stone and a little bit of timber, and a sort of middle range temperature that doesn't quite need air conditioning, not quite Catholic, not quite Protestant, not quite Northern European, not quite Southern European, not quite Conservative, not quite Labour. But this seems like the right, a typical typology for us. You can build anything with this. I mean, you can build 10-story office building, and it's quite pretty. And again, we were imagining, as I was saying, the only real examples of people using stone in tension are the occasional lintel and staircases. We went to a project in India, and we were put up in this amazing stone. So we were going to advise on a stone building in India, and they put us up in this palace outside Udaipur, and me and Pierre, the stonemason, are walking around the palace and realizing, oh, they have stone columns, stone beams, stone slabs. It's a trabeated stone structure. Never see that in European buildings, or maybe someone will correct me that there are those things in European buildings. I think it's very rare, and they're using stone and bending all the time, and all of those, just amazing, I think, more, superior stone techniques. So, but we were always interested in what we could do with stone and bending, and actually before that trip. So this thing is it's held up on the edges by these little stools. It spans 3 meters. They're 500 millimeters square plates, 40 millimeters thick, and they're clipped together at the edges with little washers. So there's a washer on top and a washer underneath, and the bolt goes between the gaps. So it's just done for expediency. We built it in the V&A as an exhibit for the V&A, so we thought we'd try something out while we were going there. But basically, that stone is supported on 3 points, so it's stable, so it cantilevers out from that corner. This stone is supported on those 2 and on the previous stone. And this one is supported on those 2 and the previous stone, and that one on the previous stone, so you end up with a reciprocating grid of square stone plates. You think you have gaps running in both directions all the way across. Any engineer would be like, oh yeah, that's going to fall down straight away, that's never going to work. But actually, it's kinetically locked together, and like a tile puzzle. So kind of Mickey Mouse slide the tiles around, exactly like that, tongue and groove connections. So we're able to span 3 meters and 40 millimeters thick stone with a safety factor for domestic load, which is really stiff and quite redundant. You can break quite a few of the tiles before it falls down. That's quite an amazing trick. And there's an incredible gift that doesn't play on a Mac. So we were thinking that, building all those things together, bringing all those things together, you can make post-tension beams, reinforced columns, you can make slabs, put the slabs together, deliver all this on the back of a truck, and take it to site, upcycle it, take it down, build it somewhere else. Complete replacement for concrete frames. Some people are saying, oh, that's all very well, what about the logistics? It's like, what are the logistics of a material that goes hard in an hour and a half and has to be delivered on a truck with a revolving tank on the back? Completely ridiculous. What we used to is ridiculous. What we could do is maybe easier. But we were thinking that, so I mean, here we're trying to copy concrete frames, really. And when, sure you've all seen Iron Bridge, but Iron Bridge is carpentry detailing. It's all mortise and tenon joint, because when they designed Iron Bridge, they only knew wood. They didn't know anything else. And when they started using concrete, all those churches in Los Angeles, neo-Gothic concrete churches and neoclassical, name Maxwell Ayrton and Owen Williams, the engineer doing the Empire exhibition, and Owen Williams getting really pissed off with Maxwell Ayrton's treatment of concrete like stone and not allowing it to move forward. And in a similar way, with approaching stone as a new material, with new technological means and a new understanding of structure that wasn't available. And the new technological means are really diamond drills and high tensile cables, and those are the 2 things that make this possible when it wasn't possible in 1850. But we're thinking it's concrete, but then we're saying, well, is it concrete? Or is it steel? No, we're going to have little steel end connections, and we're going to deliver these as a stick system and build them as a steel frame rather than as a stone frame. So it's really a material in want of a typology, and that will only come through habituated use, very difficult to predict, and in the hands of manufacturers, rather than, but I think it's very interesting that it's a kind of open field. And so from 7,000 years ago to 2019, Blade Runner, but these buildings built with granite post-tension stone. I think they had a lot of global warming in that scenario, didn't they? So probably not. But, the end.
Thanks. Dialogue, questions. I'm not going to ask a question. I'm here to put me in the drink.
Oh, thank you.
Meanwhile, when you were talking about the idea of us not being Labour and not being Conservative, all I could think of was a hung parliament.
Yeah.
From an engineer.
Oh, yeah. Yeah.
My attention to general. But it was in time, couldn't get out of it.
Oh, I see what you mean, sorry.
Yeah, sorry, well, I wouldn't know yet, but I didn't think I had to explain it.
So,
Okay.
so the stone is the radical. I mean, the timbers, we kind of know quite a lot about how to use timber in what it should be. There is an argument, I think, that use CLT is a really bad use of timber.
Yes.
It doesn't use its strength. But stone, I think we're all so scared, so frightened, so innocent in a way. How do you persuade the clients, or who you introduce the stone, or your clients introduce the stone, or these are these radical millionaires who want to do something different, or
Yeah, well, so, I mean, I think...
what's the change? It's about how do you change
Yeah.
attitudes?
So we're doing, we're looking at an energy centre for a big developer, which is lots of chillers and plants and stuff, which would normally be on an oil rig type steel frame. And we're building this energy centre as a paragon of sustainability. We're really worried about embodied carbon. So I'm really wanting to make stone boring. Yeah? I don't want it to be architectural and interesting. I want it to be dull. I want to see it on the back of trucks, people ignoring it, you know, and that it's, you know, that it stops being seen as a luxury material, starts being seen as just an ordinary building material. So we're proposing a stone frame for this thing. It's a big developer, and it's the first time we've worked with them, so I'm a little bit questioning my own wisdom, proposing something so wacky, but then we didn't get where we are by being conservative, I think. But yeah, so they were saying, why would we do that when we can use recycled steel? So like recycled in the sense of buying old beams and putting them back in the building. I think, well, that's not carbon, it's still steel. If you use it, somebody else has to go and dig it up. Because there's 1.9 billion tons of steel produced every year, only 25% of it is recycled. And so even if you're using recycled steel, or the other one is GGBS, why don't we use GGBS? And GGBS comes out of a blast furnace. You know, so for me, I'm seeing fire in all these processes. So the thing, if you really want to decarbonize, this is the option. And then they're like, well, that sounds quite interesting. And how many people can make it? You know, so it's important that there are 2 or 3 manufacturers, and we've shown, well, we did this 600 crazy staircases and 3 or 4 buildings, and here are some examples, and they're the one in the RA, and they, you know, you need to build up, and by doing it on a back extension, and then a slightly bigger job and a bigger job and a bigger job, we're able to build up enough track record that someone doesn't think that it's a complete leap into the, you know, if we proposed it, we'd never done it before, maybe we'd never do it. But the carbon argument, I think, is just so persuasive. It's, I mean, in the case of the energy centre, it's 10 times less carbon to make it with stone beams, and they're the same size as the steel beams, and they don't need to be repainted after 20 years. So, but yeah, you've got to be tenacious. I think. I mean, we do unusual things, and we're normally, yeah, it's not good for us economically, but we're quite tenacious in pushing silly solutions and silly, unusual.
Do you think would you do some kind of open source design guide?
Oh yeah.
You're almost like you're sort of trying, what if it's called SC3 and SC4? You can go to the bit of the old building regs and you find the joist sizes with the spans and all the centres and all that kind of stuff. Would it be worth to really get the ball rolling?
I was talking to a publisher about writing a design, like a design guide. So we sort of pretty sad. So the issue with, I mean, the interesting thing about this, and one of the issues with it, is that there's no codification for stone structures. And personally, I quite like that. I find it. So, like
As a
brickwork.
business model, I mean, you need to prove it every time.
Well, you do it from first principles, and you're not kind of like trying to lock into someone else's way of thinking. But we spoke to people from the standards agency, and they're like, we will only make a code where there's a demand. So it's like, oh, so you'll only make a code for a material that's already in use, which means that if we're only going to build stuff with a Eurocode, we're going to carry on building what we're already building. There's, you know, there's no, you know, what do they call geothermal father really pushed glass forward. There's no standard, still no standard for that kind of use of glass. There's a kind of design manual today where, yeah, all the time. And so I think that's yeah, kind of an inhibition in its adoption. But
very good comparison, actually. You had stone and glass for the two guys from, but they insurance is, I mean, a really boring question, but I mean, I'm having conversations with insurers about how you're going to insure the future that's not known, because you can only insure on the basis of what's happened before, and that's no longer possible. So what are you going to do? And anyhow, it costs us all a fortune and doesn't serve clients. So why do we bother to do it? And why do we pay you all to do all this stuff? A huge amount of money, huge glass buildings in the city. Why do we pay you to do that when you're not actually doing anything very useful? Yeah. So do you have arguments with?
We've never had any questions on insurance. Timber comes up all the time. Stone, it's like we're using stone, and they're like, oh, that's
But they don't know how you're using it.
But then we've never had a really serious, and I think there is. I mean, I was joking about the not quite Protestant, not quite Catholic, not quite left, not quite right. But when you walk into a design meeting and you say, let's use DLP, they're kind of looking for your sandals under the table and wondering whether you're a communist. Whereas you walk in and you say, how about stone? They're thinking, oh, like Mussolini. It's a right-wing material. Very comfortable for insurers.
So what's the lifetime of the tension?
Well, if it's not wet, it'll last forever.
Well, it is wet.
But if it gets wet, then the limestone is alkaline, and concrete protects the reinforcement through its alkalinity, and all the concrete buildings that are falling apart are because the carbonation of the concrete, atmospheric carbon is going into the concrete and making it acidic. And the minute that acidity hits the rebar starts rusting and everything falls to pieces. So in our case, not only are the limestone is alkaline, it's surrounded in grout, and the cable is right in the middle of the stone, so it has more like 100 millimeters of cover in each direction, and more enveloped. But I mean, we're not the only people using post-tensioning. You know, every motorway bridge in the universe is post-tension concrete.
I mean, your RA brief, I mean, that is very fine.
Yeah.
Depending on those cables.
But I think, steel is, I mean, unreinforced. So we're doing reinforced stone, and we were talking, and people are designing a lot of stone in France, and we were talking to French engineers and architects, and they're like, oh, why are you putting steel in stone? No, it's not natural, you know, disgusting. And they want to be puristic, you know, and they want to do vaults and stuff like that. And we're more, not quite so dogmatic about, but I mean, I think the issue is, Philippe Bloch is doing all these amazing shell structures, very, very efficient, but you can't walk around on a shell, on a curved shell. They're kind of limited in their utility because you don't want, flying bolts hanging down in all the rooms. So designing a radiated stone system rather than a bolted stone system.
And a lot of your tension cables are exposed as well. So what happens to the fire?
Which one?
You're on your underside, you've got protection cables, staircases.
Oh no, they're inside. They're inside.
Okay, they're all
inside. They're all inside. So the first one we did, we put the cables underneath, but in general they're inside.
I'm just thinking about our liability, which I think is.
Yeah. No, I mean the fire test. I really thought the fire test would be a problem, and we had quite a lot riding on it. And when they were burning it, after 45 minutes, there was a big crack appearing, and I was thinking, oh god, that's the end of stone because of fire. It's going to kill the thing. But it just went on and on and on for 3 hours. So.
We did a house in 1780, the Rob Allen house, and that had, when we took the structure of the floor, structure of the ceiling, when we took that down, they were tree trunks, which were charcoal.
Yeah.
They've been burned so many times over 300 years.
Oh, wow. Yeah.
Same thing.
Yeah.
Didn't go anywhere.
Yeah.
Right. And that properly just killed its own fire.
Yeah.
And kept the structure.
Yeah.
So it sounds like you're going to say more.
Well, I think the thing about the timber and stone composite is that it gets, so obviously with CLT, people are worried about the CLT adding a huge additional fuel load in a fire situation and delaminating and continuing to burn. They're not so worried about small timber elements because they don't have that much fuel when they're stuck together. So having the kind of stone and timber combination is good in a fire situation. It's good for the air conditioning and it's good for the acoustics and structurally. So I think that's the advantages that CLT doesn't.
You written a book? You written a book?
No.
I think you have.
No, I was gonna, when I have time, I was thinking about writing a book.
Write this down. Well, however polemical it is or however practical it is, it seems we're in a sort of supercharged political age of fear of what you can say and what you can do, and it's all about who's doing it and what they're doing. At the same time as the planet is kind of going pear-shaped. And what seems so important about this is it actually is addressing some pretty fundamental questions, but and to get people, it feels like we're at the cusp of something's got to happen. I'm not I suppose I'm not being technically, but it sort of feels like it's the beginning of there has to be a kind of new polemic. There has to be a new generation of creative, because at the moment we sort of seem to be stalling.
People are really wedded to, so obviously contractors are wedded to building steel and hot rod, and whenever we've done timber buildings, have to fight quite hard to push contractors away from, because obviously contractors are difficult and full of risk, and why the hell would they want to do something they haven't done before, because everything goes wrong anyway, so for them it's like a massive headache. But I think also architects quite often, I've said, oh, should we make a timber building? Like, oh no, I'd really like to see the slim lines of steel. Like, it's not very good for the environment. Does anyone really care what it looks like that much? There's a lot of adherence to materials for aesthetic reasons and not wanting to let go. But I was thinking, if you see a big fat sausage sandwich with melted butter and pork fat dribbling out the side, you know that this is bad for you. And when you see a steel and concrete building or a big concrete building, you should have the same visceral reaction. This is a big, bricks and concrete. This is like pork fat. Huh?
Even though it's bad for you.
Yeah, I know. But still want to have the top. Yeah, everybody wants the top. Yeah, but maybe you do it occasionally, just.
Would you say a little bit about foundations? I guess in terms of like timber versus stone or hybrids and kind of carbon and cost implications of this. Do these stone, does that have big concrete foundations?
I mean, buildings have a great big basement underneath. We tried to make what we wanted to do with the other think about the basements being circular. What we wanted to do was to open cut a basement, build a stone wall, waterproof it on the outside, build a French drain around it with glaze core, which is expanded glass, foam glass leftovers. So you have the insulation, the drain cavity on the outside, and the waterproofing on the outside, and it's circular, so it's 100 millimeters of stone, and the stone's exposed on the inside, and it's just sat on the ground. I was thinking that would be a really kind of poetical solution, but with that, we started off with a kind of bubble-shaped basement for Amin's one at Swanwood, and we had so many fights with the contractor that basements put concrete in the ground, so we ended up concrete. But normally people are building trench foundations 2.5 meters deep because of the clay. In the 1950s, you would have built a little pad at the bottom of the hole and built a brick here on top of it.
So surely that's always a positive about using timber over stone, that there's always going to be less.
Yeah, no, and using timber timber will be, the building will be lighter. Stone building depends on what it is. It could be lighter or could be heavier. But it's not, most foundation, well, I think there are two things. Mostly people kind of lazily stick big strip footings in everywhere. They're 2.5 meters deep, and they're very heavy, and actually intermittent footings or concrete footings down holes with piers on top would reduce it quite a lot. The concrete doesn't have to be concrete, it can be stone. But there's another thing about collectivized risk that I was always quite interested in. So if you have a Victorian street, they have no foundations. They're just cobbled brickwork. Nowhere near any compliant depth, and maybe 1 in 10 have been underpinned. And now if you built them, they would have full strip footings 2.5 meters deep right the way through, and none of them would have had to be underpinned afterwards. But the cost of proofing the whole street against subsidence is far in excess of the cost of fixing the 2 or 3 houses that are going to suffer from the subsidence in the first place. So a kind of mutual insurance for shallower foundations would be far more economical, the kind of collectivization of risks for foundations, because everyone's trying to always avoid every risk in totality rather than sharing the minor risks. What's his name? Partico's theorem. 80% of the return for 20% of the effort. Sorry, that was a total ramble. Partico's theorem of foundations. 20% of the foundation, 80% of the houses are okay.
Is there an optimum grid size or span for stone? Like timber, when we've looked at embodied carbon, timber tends to be better. If you're looking purely at embodied carbon, timber will be better for shorter spans, maybe 4, 5, 6, maybe 7 meters. If you're looking at larger spans, you tend to be better off looking at PT because the actual amount of material you're using is less.
Yeah.
Whereas timber is not so efficient for such large spans.
Well, stone span for span will be shallower than concrete because it's stiffer. So, and will be about the same as steel, a little bit heavier. Much better than timber. I mean, timber, the limitation is the span, so you end up with steel hybrid buildings, timber floors in them for that reason. So we're thinking having stone frame with CLT floors, might be a good way of making longer spans in that kind of hybrid building. But you see, but yeah, you're right, like 7 meters CLT, maybe 8 if you really pushed it, but it's quite a limitation because of the bounciness issue. But the hybrid buildings where they mix steel and timber, the sky buildings like that, and Google. I mean, Google, they're like, oh, this is the biggest timber building in the world. Oh my God, you have to squint between all the bits of steel and aluminum, like spy a little bit of timber in there somewhere. But
it's about types of stuff, like types of stone.
Yeah, so we are generally using limestone because the stonemasons that we work with come from that kind of traditional background. We were looking at stone in the UK. The quarrying industry is not very sophisticated. It's far more sophisticated in France and Portugal and Italy, especially Portugal. There's a big quarry in Larvik in Norway that we were talking to recently, and they were saying that they have 80% wastage because it's the wrong colour, and the quarry is right next to a port, so they stick it in a container and it goes straight on a ship, which is quite low, so it comes to the UK quite low carbon. Granite is a bit stronger than limestone and marbles.
Is it really hard to work?
Yeah, granite is harder to work, and you get silicosis from working granite that you don't get from, so limestone is much safer to work. But I was really, so limestones are like 100 newtons, maybe 50 to 100 newtons. Granites are probably up to 150 newtons. I'm really interested in getting gabbro, which can be 250 or 300 newtons. It's like a really dense stone, like a 300 newton stone. We could make tiny, much stiffer, make really tiny. It's black, it's going to look like future alien stuff. But they don't sell much of that. So
just to come back to that, one of the beautiful things about the British stones, the limestones, is they're actually quite soft. They look quite beautiful. They're different from the Jura stones or the Polianos, Portuguese stones. Are you saying really we need to look outside the UK to do these more heavily engineered solutions?
I think we have loads of stone here that they could use, and we're not using, in Lyon, for example, in France they have a tradition of removing massive pieces of stone from the quarry and putting massive lumps of stone in the building because it's more expedient than cutting it to bits and putting it back together again. But because we're threading little bits of the stone together, we don't have, so geology in the UK in limestone, for example, is tending to produce smaller blocks because the beds are smaller. It's just geological. But there is no reason why we couldn't supply our own stone. There's loads of granite in Cornwall or whatever. It's just, will anybody do it? So imagine the Green Deal, you know, the government's going to invest all of its money. Can you imagine how cheap it is to make a stone beam factory?
And how work with Cotswold stone, for instance.
Yeah. Yeah, but those stones would be expensive, and Portland is expensive because it's in demand. And we're doing a vault, big truncated 10-meter unreinforced vault for a museum in Lincolnshire at the moment, and they wanted to use family stone, which is an Ancaster limestone. It's like 1 Newton tensile strength. That's like, we want to use this. It comes out in tiny blocks, you know, and we were doing everything to persuade them to use something else. But there's this kind of, it's this sort of nationalism, patriotism, almost British stone, you know, it's like, it's not British stone, it's just stone.
I think you have a question the resistance to the use of this sort of technological carbon techniques is cultural. Because we've done this in this place for 100 years.
Yeah.
Because the architect wants this, because he feels, he thinks the architecture should be done like this, which is another cultural problem. And picking up also the comment on how to trigger or trigger the paradigm shift. Have you ever thought about how this might happen?
I don't know, I was going to do a lot of talking. I'm going to do a lot of talking at events. Persuade architects to build with it. I think that's why.
Do you think it's a series of enlightened professional people like you can lead the charge, or does it require a top-down approach?
Yeah, I think
I thought it was something very interesting that you said. It's like make the material more expensive, and that's carbon, not labor.
Yeah.
And sort of,
yeah. Well, I mean,
does it
yeah.
require that sort
Oh,
of
totally. If
intervention,
you moved tax from people onto carbon, you would have less global warming and more employment, higher value skills. We could lower all the factors of safety, be a lot more careful because we do it more slowly, you know, and all kinds of things would come out of that. But no one's ever going to do that. Would require a global coordination.
Sure, capitalism would be that virtuous.
No,
just extract the profit.
Well, I mean, that's it, isn't it? So it's GDP, you know, getting stone out of the quarry and reinforcing it and sticking it in a building is a lot less GDP than taking steel out of Brazil, blast furnacing it, rolling, milling it, fabricating it. And, you know, it's in the interest of GDP to have circuitous manufacturing. And
the Treasury doesn't do carbon tax because it's inevitably going to fall. So the rate of income falls because the carbon tax, when the carbon tax kicks in.
Yeah.
So it's a brilliant idea. We need to do it, but the Treasury won't have it unless we can find a way of
But they don't say the rate of employment's fallen because we have income tax.
No, but they love VAT because it's
VAT. Yeah. But I think if we, you know, this government has hardly any industrial policy. Labour's talking about having an industrial policy of some kind, but Christ knows what that will be. I don't know, but I think it's very easy to build a factory to make stone beams. Very little investment. You know, for the cost of a nuclear power station, you could be giving the stone beams for free to anybody that wants them. It doesn't seem that difficult to me, but what do I know?
There are still kind of buildings built now in Cornwall or Wales where stone's imported from China, or stone or granite or slate are imported from China or Brazil because it makes economic sense for someone to do that rather than dig it out of the hole next door to the side.
Yeah.
And surely we're kind of the wrong audience for the problem.
Yeah, maybe. Yeah, I think. I mean that happens because it's cheaper. So someone in China is earning no money doing whatever labour they're doing to produce these things, probably living in terrible conditions, and somebody here doesn't want to pay that. And somebody here is more expensive, so they're going to be more wasteful in their design and need more of it, you know. And so it's kind of, I don't know. I guess if labour costs the same everywhere, then you wouldn't have that.
Is labour is that the main barrier to why stone hasn't been taken up for post-tension stone?
There's no barrier particularly. It's just that nobody's done it.
Yeah.
I mean, Portcullis House. Well, Portcullis, Hopkins did it on Emmanuel College and Portcullis House, and Peter Rice did it, and Seville.
Did they do
Expo
post-tension stone?
And Renzo Piano in the Padre Pio church. So we're not the first people that are doing it, but it's just kind of exotic, and I don't think. We did quite a few stairs before I started thinking about how much carbon was in the stone. And it was kind of a revelation to discover that, stone's really low carbon, of course, because it's already there, you know, it's not manufactured. And when that it's the stone, reinforcing the stone idea is not new, but the fact that it's a low carbon solution, those two things I think make it a material.
So you wouldn't say labour is an issue, it's more just the lack of manufacturers?
Oh yeah, I don't think it's labour. I think, well, I guess quarrying is much more industrial in France, and nobody here wants a quarry dug up near there.
Did you say there are only 3 manufacturers? Who are the 3 manufacturers? Like,
well, 3 or 4
3 or 4.
stone fabricators.
Are they all French,
do
or are they all French?
Well, the
Any on
guys
side?
we work in are French from Lincolnshire. There's a company called Atelier Romeo in Italy. Zerelmi are doing a stone stair with us, with Stanton Williams at the moment. Extension stone stair.
But what kind of size do they operate at? Like, could they do a commercial office building?
Well, the big one, the £75 million one, is a £4 million stone contract. So that's a huge. I mean, that thing is just a massive. This thing is it's huge. And there's more stone in that, you know, I mean, that's really wasteful in terms of stone because it's quite architectural, but make a really big office building with that much stone, with that much labour. So I think there's no.
Where is that being?
It's in Henley.
With whom? And is it an office building?
No, it's a house.
A house.
Yeah.
£75 million house.
I don't think I'm supposed to have said that. No, it's not.
Your secret is safe with us. I'm from the private house.
75 million and a half.
So just going back to the podcast, in terms of because it's a natural material, how do you check the floors or the seams of a different material running through it and then dyeable foam, that sort of break?
Yeah. So we take samples, and I mean all of this is very undeveloped, and people did 1 million PhDs into concrete and steel, and as I said, our R&D budget is £2.50. So we take random samples from the stone, and we make a statistical normal distribution, and we take a 95% confidence. So we test lots of bits of stone in different orientations to the bedding plane. We take the average, we work out what's a 95% confidence safe value, and then we put a factor of safety of 3 on it. And stonemasons select the stone, and they were telling me that, oh yeah, you hit it, and a good stone rings, you know, and a bad stone doesn't. And I was thinking, you sound like people in markets slapping watermelons, you know. But actually, if the stone is complete, it does ring, and if there's a flaw in it, it's completely dead. I'm quite surprised how obvious that is. But we've tried to correlate ultrasound readings with, so we're always, in a quarry there are different benches, and you ask them how strong the stone is, and they go in the back of the filing cabinet and pull some test certificate that someone did for them, and you have no idea what you're really buying. And we were thinking as the benches progress, the strength changes, but we get all kinds of quite a lot of variation, and not really understanding why. And it occurred to me that actually the variation is probably vertical, that in the line, you know, the years that the limestone was formed, probably there's a strength at a datum, common strength at a certain datum.
More shells of a certain type, or more pressure.
Yeah, or just more pressure, or better weather, or whatever. I don't know what it is. So if there's a future in stone, someone much more intelligent than me will figure out X-raying and ultrasound and spectrography of stone deposition, different materials. I don't really know.
Do you work with geologists?
Yeah, well, I've spoken to a lot of geologists. It's quite funny how, it's interesting how people from different fields view things in different ways. So for us, it's stone, you know, and they're like, you know, what do you mean stone? You know, stone's a completely different material, granite from limestone or tuff or whatever, and behaves in totally different ways. And so we just sort of stick it in a bracket and do some tests and take a big factor of safety, and we're very pragmatic about it. But I think somebody set the task of understanding what in limestone gives it its strength or its weakness, and how that can be tested and identified would be super useful. But beyond
you talk about structural and performance of stone, but you talk very briefly about environmental performance.
What, sorry?
You talk very briefly about environmental performance, acid cooling, acidity.
Yeah.
Talk a bit more. Is seems to be very interesting to use the material for other reasons as well.
Yeah, I think it's, well, I think we, oh, where did I put it? I mean, so this building, and in this, in it's concrete and timber, but I think there's a really obvious compromise between lightness and weight, and it's doing, you know, the structure is doing something about, you know, you think the ideal building would be a completely passive, imagine 4 layers of very thin stone, you know, and just hits the right temperature all year round, you know, no matter what. You know, Everly, nickel, Einschlager, Everly 22, 26 or whatever, but you can have a building that has no active systems, you know, and those steels would be amazing. But I mean, this is the step where, you know, you're tuning the, so we do the M&E and the structure together, so we try and tune the structure to suit the M&E, you'll get less M&E, not always successfully, but in that case, I think it's quite good.
Let's talk.
Mark, is that yours?
Yeah.
Steve, can I ask you, what do your fellow engineers think of what you're up to? Are they, I asked the question, so I just think, are they following your heels, kind of chasing up, this is the kind of new thing that everyone's going to want? So if I say to one of the engineers we probably often use, oh, we do this building in stone, I can imagine I probably don't get very great response.
Yeah, I think,
ideally we all come to you and use you because you're the expert. Actually, for it to take off, you need.
Yeah, no, we were saying,
engineering.
yeah, we were saying this that for, you know, we were talking to the stonemasons that we were and saying, look, we are never going to get any big jobs for you unless there are 3 companies like yours ready to deliver. And so you should really go and teach your competitors how to do this competently, which is totally anti-intuitive. And but you know, you'd rather have 30% of a massive market than 100% of a non-existent market. So, and I think we would be the same, teach other people to design in stone. And I don't think, I mean, you know, I think many of the big engineering practices are very conservative, and many of them are going around saying steel, or they're what is it, SEM-free, you know, decarbonized cement, going to make it with hydrogen. We're using GGBS, which is a waste product, and SEM-free because we stick an alkaline accelerator in it, or recycled steel with 0 carbon because it's already there, you know, and all of these ideas are leading to a lot of inertia and a lot of engineers saying, you know, we have to decarbonize steel and concrete, but I think you have to let go of steel and concrete. You know, you can make faster and faster steam engines, but eventually you're going to be driving a diesel train, you know, and it's...
So are you working on them as well? I mean, are they an obstacle more than, I mean, I can imagine architects love to use stone. I'm not completely convinced, you know, but what you're saying there with the timber, the steel, the lightweight, you know, fantastic.
Yeah, I don't,
How many engineers in the room?
Kind of.
Oh, you're...
There you go.
Yeah, I don't know, you know, there are engineers and engineers, aren't there? There are really conservative, boring ones who do the same thing over and over again, and there are more adventurous ones. So Arup were doing Sagrada Familia's post-tension stone tower, and all the staircases inside, so they're doing it. And I think, you know, you need to be quite unwise to walk into a big commercial client and say, you should know you're building out of stone. You know, I think it's not good. It's not, our company doesn't grow as fast as other people's companies because we're a bit more kind of out there, and I think it's probably not good for business, you know. Good for business to say, oh, we'll use decarbonised concrete so you can be completely in your comfort zone, and yeah, all the SEM-free stuff, oh, we'll just use SEM-free. Everyone's totally in their comfort zone with SEM-free. And what is it? GGBS. Came out of blast furnace, imported from China.
At least you've got fire guys on your side.
Yeah. Yeah.
Have you tried specifying English though?
Yeah, we have used some. So the beam in, Albion gave us the beam in the RA for free, whatever that is. And it's the Roach. So that was Roach bed.
Bloomberg opened a quarry, didn't they, when they did their particular...
Did they? Yeah.
Well, they did us. Yeah, remember Bloomberg did that. They opened a quarry to do their cladding.
Yeah.
So they do exist. course.
Yeah, no, there's definitely, I mean,
Expensive
there
building.
are quarries and there's definitely plenty of stone. There's no shortage of stone.
The thing is,
It's
the
just-
quarries exist, you're cutting from the existing scar, so
Yeah,
you think it wouldn't be such a
yeah, I think we went to see the Clunch quarry in Tottenham, outside Luton, and it's like chalk, like white stone, very soft.
next to Smetworks.
But that guy comes up and he's like, oh yeah, I come up here in the summer because the water level's down and I dig out 3 boulders and I cut them up and I sell them. And I'm like, how much a cubic metre? And he goes, oh, I don't know, I'll give you a price per tonne. And it's like, it's just one guy cutting the stuff up. And you think, whereas in France, we saw that Minecrafty, where was it? Kind of, I mean, this place is, you can't see it very well from that shot, but I mean, it literally looks like Minecraft. They have these great big chainsaws, and they cut in rows, and they cut sideways, and they just cut giant blocks out. You know, and,
make big noise as well when they blow them up.
oh no, there's not. There's no blasting. It's just sawing, and they're just sawing block after block, and they make 2 metre by 1 metre by 1 metre blocks.
Is there any economic argument, you know? Is it cheaper, more expensive?
Well, I think we can. So steel prices are going up, but when we're looking at this energy centre, I think that we, using the waste from the granite quarry in Norway, we can pretty much get to the same price as the steel, or the steel plus the first maintenance. So, and that's without any development. I mean, obviously, you take stone out of the ground and you make a beam with it, versus you take stone out of the ground, you crush it, you burn it, you mix it, you send it to a batch, and all this stuff. You know, clearly it's got to be cheaper in the end if you industrialise it. But I think even now it's not too bad. I mean, Taha built his building like that. I mean, it's his money. You know, he wasn't squandering it. It wasn't that expensive. So.
And compared to concrete?
Yeah, same. I mean, well, steel and concrete would be normally buying with each other for price. So, yeah. I mean, it's difficult to say. It depends on the stone. The minute somebody comes along and says, "Oh, that's really nice. Do you have it in a flawless beige?" You know, then prices go up.
Do you use this
Pink
same?
and green granite. Sweden is full of pink and green granite. They used to make worktops out of it in the 1960s or 1980s or whatever, and it's a great structural material. So I really want to make a structural frame out of pink and green 1980s kitchen worktop. Really lurid, you know, mortadella and spinach. You know, it's quite, it's great.
With mirror glass.
Yeah.
You can't get a lot of microcrystals.
Yeah, I think it's beautiful. Yeah. But I think, but that, I mean, I was putting up the Blade Runner thing, you know, when you see any Ridley Scott film and you wonder, what is all the stuff made of, you know, all the alien stuff. And Calatrava's buildings, I worked for Calatrava in saying that he would never let you use any industrial components, no eye sections, no beams, no nuts and bolts ever could be visible, you know, and so you arrive at those buildings and you're like, this is alien craft, you know, it's not like this, you know, it's not identifiable with. And so the kind of idea of making, so we were going to try and make a space frame pylon with stone, so very, very thin gabbro stone beams would be just sort of black flutes, you know, and connected together and all pink and whatever, and it would just be this incredible unidentifiable language, you know, which really interesting. Oh, Potsland, yeah. Yeah, that's low carbon if you can find enough of it.
Well, the whole system's covered in it, and they have to pay to get rid of it.
Is it?
Yeah, they have to pay £300 a tonne, which is bankrupting all the villages because they can't rid of it.
Oh, because it's come off of the...
Coming out of it. So they have to sweep it away. It has this waste, so they have to pay.
Oh, yeah. I mean, that's a great...
There's a guy
I'm giving the wrong talk.
And Gav just pointed out.
Yeah, Potsland is concrete. That's the future. Forget all this.
I don't think having an article, Steve, that's excellent. I mean, I think what you end up doing is giving us some hope. The kind of idea that building can once again be a creative act with actually how the grain, the fine grain and character of a structure, something just taken for granted, something which is often covered up. So for that, it's wonderful. And the idea that with that we might get a more sustainable way of building. So whether it has to be open source, whether you need to, you should go and talk to Labour. You need to be going to talk to the politicians. But anyway, Steve, thank you very much.
Thank you.
Parachuted, Henley, Finnish architect. He's here on the 5th of July. Probably about 6 weeks. It's another Wednesday. Talking about Alto, Hemio, Sanatorium, and Finnish. So do come back.